Alright, so today we're going to go over factoring methods. I'm going to start off with GCF factoring. GCF standing for greatest common factor. Okay, so what we're looking for here with this type of factoring is we're first wanting to identify how many terms there are in an expression that we're going to factor. Alright, so terms are things that are being separated by a plus or minus sign. So here, this first example has two terms. Here's our minus sign. So 72 is a term. 81x is a term. Right? This one has two terms, separated by the minus sign. 63x squared is one term. 49x is another. Okay. So notice again, for a lot of these terms, if you're just focusing on the term, right, a term is made up of things that are being multiplied together. This 81 times x make up that term. This 63 times x squared makes up that term for this expression. Okay, so now get back to the factoring. So for GCF factoring, we are looking for the greatest common factor. What is the biggest factor that can be divided in both and all the terms involved in the expression? Here we only have two. So you got to think, what is the biggest number that goes into both 72 and 81? Okay, so now some of you may be thinking 3, right? 3 definitely does go into 72. 3 does go into 81, but it's not the biggest. We want to make sure we're finding the greatest common factor, and that for this one would be 9. Now, our GCF is just going to consist of that number 9, right? Sometimes GCFs have a variable involved. However, for this particular example, since this first term does not have a variable associated with it, it cannot be part of our GCF. Right? So this 9 is our GCF. So now when we're factoring, we want to make sure we include the GCF. Right, and a set of parentheses. Inside the parentheses for GCF factoring is the result of when you take each term and you divide it by the GCF. 72 divided by 9 is 8. Negative 81x divided by 9 is negative 9x. And there we go. Now we're done. There's that first example. Second example. Looking at these two terms, what is the greatest common factor between these two terms? Look at the 63 and the 49. The biggest common factor they have in common is a 7. Now, here, both these terms have an x in them. So, you've got to know that x is going to be part of your GCF. Now, this one has an x squared, so it has a 2 for an exponent. This one has a 1 as an exponent. So when it comes to exponents for your variables in your GCF, it's always going to match the lowest one. So that would be x to the first. Okay, so there's our GCF. Now we're going to do a little division. 63x squared divided by 7x is 9x. Negative 49x to the first divided by 7x to the first is negative 7. Now the way you can check to see if you factored it out correctly is by taking your GCF and multiplying back in. So if you distribute the GCF through the parentheses, you should get the original problem, original expression, right? 7x times 9x is 63x squared. 7x times negative 7, negative 49x. Next example. Okay, so again, if you don't see a number in front of a variable, assume it to be 1. So I'll throw a 1 in there. Okay, looking for a GCF. The biggest number that goes both into negative 1 and negative 7 is 1. Now we're also going to make it a negative 1 because our leading coefficient, right, it's the coefficient of your leading term. If that's negative and there is a GCF, a negative will be part of your GCF. They both have n's. I'm going to have n to the first because n is the smallest exponent. Alright, so we're going to go ahead and divide negative 1n cubed divided by negative 1n to the first is n squared. Negative 7n to the first divided by negative 1n to the first is plus 7. Alright, so now here we have 3 terms. Again, it doesn't matter how many terms there are. If you're doing GCF factoring, it's what's common for all the terms involved. So now we're going to expand to 3 terms. I've got an 8, a 4, and an 8. The biggest number that goes into all 3 of those is a 4. This has x cubed. This is x to the first. This doesn't have an x. So therefore, our GCF is not going to have an x. Right? Because this last term does not have one. Right? It's got to be common to all. Right? 4 can go into all of those, but since all of them do not have x's, your GCF is not going to have an x. 8x cubed divided by 4 is 2x cubed. Positive 4x divided by 4 is positive 1x. Positive 8 divided by 4, positive 2. Okay. Next, greatest common factor between the numbers is 2. And because our leading coefficient is negative, our GCF is going to also be negative. I've got x to the 9th, x to the 3rd, x to the 1st. Since they all have x's, we know that our GCF is going to have an x. And in terms of an exponent, it's going to be whatever the smallest exponent is. Alright, so let's go ahead and divide. Negative 2x to the 9th divided by negative 2x is 1x to the 8th. 4x cubed divided by negative 2x, negative 2x squared. And positive 4x divided by negative 2x is going to be negative 2. Now the next example, okay, we got to make sure we're able to identify how many terms there are in the expression. The most common mistake that students make here is they're going to go ahead and distribute through the parentheses. Okay, so again, we're factoring, right? Distributive property is the exact opposite of factoring. So if you're going to multiply, you're going backwards. Right? There are 2 terms in this expression. Right? Here's one, and here's the other one. Right? These 2 are separated by a minus sign. There are 2 terms in this expression. Okay? So now we say, what do these 2 terms have in common? They have this x plus 1 in common. Here's an x plus 1 right here, and here's an x plus 1 right in there. So that is going to be your GCF. Right, so again, we're going to group them together, so we're going to keep the x plus 1 in parentheses. Right, so now what we do is, this is our GCF. Clearly that's what they have in common. So now we're going to divide. This term divided by the GCF, well, those x plus 1s are going to cancel, so you're left with 5x. This term divided by the GCF leaves you with 3. Right, again, the way you know you did this right, I can take my GCF, distribute it through the parentheses. X plus 1 times 5x is 5x times x plus 1. X plus 1 times negative 3 is negative 3 times x plus 1. Alright, so I'm going to pause here for a moment. I want you to pause the video, and I want you to see what you can do with number 7 on your own. Alright, so I'm going to pause the video now. Pause the video. You can go ahead and pause. Alright, so these 2 terms, again, terms are separated by a plus or a minus sign. Here they're separated by this plus sign. They both have that 2x minus 1 in common, so that's the GCF. So here's GCF written up front. Inside the parentheses is going to be what's left over after you divide. So this term divided by the GCF is just going to leave me with the x. This term divided by the GCF is just going to leave me with the plus 4. Alright, so now the last type of factor we're going to talk about here is factor by grouping. So now what's important to know about factor by grouping is that you must have exactly 4 terms to do this factoring method. It has to be 4. Unlike with GCF factoring where we had 2 terms and 3 terms, and sometimes we could have 4 terms or even some weird looking terms, right? when it comes to factor by grouping, you must have exactly 4 terms. Alright, so that's why you can see with these last 2 examples, we have exactly 4 terms. Alright, so to do factor by grouping, you're going to first start off by grouping 2 terms at a time. Now we need to be careful when we drop these parentheses here. Remember, the purpose of these parentheses is just to group them. A common mistake that students make here is they want to do some sort of multiplying of what's in parentheses like we did with the last homework. Okay, again, we're factoring, right? Factoring and multiplying are exact opposites of each other. So you definitely don't want to be multiplying anything. Okay? We're using these parentheses to group 2 terms and another 2 terms. Now with the first grouping, we're looking for GCF. Between these 2 terms, there is a GCF of 5x squared. Divide by what's left. The 2 terms by that GCF, I'm going to be left with 3x and plus 1. Okay? So now I'm going to look at these 2 terms. What do they have in common? Well, the lead coefficient is negative, so we know that's going to be negative something, and it's going to be a negative 3. All right, again, taking the GCF for these 2 terms. Negative 9x divided by negative 3 is 3x. Negative 3 divided by negative 3 is a positive 1. Now here's a checkpoint in the process of factor by grouping. That if you did this right, what should happen is you should see inside the parentheses a match. Here we have matching 3x plus 1. That's how you know you've done it right so far. But you can't stop there. The last step is to factor out that 3x plus 1 as a GCF again. And what's left over is going to be the 5x squared and the minus 3 in another set of parentheses. Okay, so I'm going to do it one more time here with number 9. I got exactly 4 terms, so we want to use factor by grouping specifically. So I'm going to group these 2 together. I'm going to group these 2 together. First 2 terms, I'm looking for GCF. 7x squared is the greatest common factor for those 2 terms. 14x cubed divided by 7x squared is 2x. 35x squared divided by 7x squared is a positive 5. Okay. Looking at the next 2 terms, GCF, again, since the lead coefficient is negative, bare minimum, we're taking out a negative. Alright, and the only number that goes into both 2 and 5 is 1. Okay, so there's the GCF of these 2 terms. I'm going to take out a negative 1 as a GCF. And that's going to leave me with a positive 2x and a positive 5 in parentheses. I know I've done this right so far because what's in parentheses is an exact match. Alright, but again, I'm not going to stop there. I'm going to take out that exact match. 2x plus 5, GCF. And what's left in the other parentheses is the 7x squared and the minus 1. Okay, so there's your final answer. Alright, so if you have any questions, please let me know. You guys have a great day.